Okay, now we're going to be solving systems of equations using substitution. So when solving systems of equations, you can do it two ways. You can graph them and find the point where they intersect. We've done some practice with that in class. Or you can substitute them. You could solve for one of the variables and replace it in the equation. So let's look at how we can do that. So first I have negative 3x plus 3y equals 4. And then my next equation is negative x plus y equals 3. Okay, so off the bat, I don't have a clear defined variable yet. So what I'm going to do is I'm going to rework this second equation to solve for one of my variables. I think I'm going to solve for y. It seems the easiest in this case. So I'm going to go ahead and get rid of that x. In order to get rid of the x, I need to move it to the other side. I see that the x is negative, and that's being added to the y. So I know I can go ahead and add x. Remember, because it's negative. So I'm going to add x. And I'm going to add x over here too. Since the x and the 3 aren't like terms, it's going to look like this. It's just going to read y equals 3 plus x. So now it looks like a normal equation. So now I can take this and plug it in for y in this equation. So let's see what that looks like. That would give me negative 3x plus 3 times 3 plus x equals 4. Whoa. So the reason I can do that is because I solved here for y. I know that y has to equal 3 plus x. So in this equation, instead of replacing y with 2 or 3 or one number like we usually do, I'm replacing it with that whole equation. Yeah, I know it's a lot, but now I know how to do this, right? We just did practice on it. So I have negative 3x, and distribute the 3 to both, so I'll have plus 3 times 3 is 9, and 3 times x is 3x equals 4. So in this one I have negative 3x plus 3. Whoa, that's weird, they cancel. So negative 3x plus 3 is 0. So they cancel, and I'm left with 9 equals 4. Does 9 ever equal 4? No. So I can already tell that there is no solution. Okay. Let's go ahead and look at another one. So on the next one, I have 2x plus y equals 20 and 6x minus 5y equals 12. So let's go ahead and try this one. Again, I see that neither one of them have a defined variable, but I see that that y is by itself. It doesn't have a coefficient. So I'm going to go ahead and simplify this one for y. So I'm going to write it over here. 2x plus y equals 20. Now I got to get rid of that 2x. So I'm just going to go ahead and subtract it. So I'm going to do minus 2x minus 2x. 2x minus 2x is 0. So I have y equals, and then 20 and 2x are not like terms. So I have y equals 20 minus 2x. And then just like we did before, I'm going to go ahead and replace the y up here with this equation. So I have 6x minus 5 times 20 minus 2x. So in this one, you got to be extra careful because that's a negative 5. So I'm going to distribute the negative 5 to the 20 and to the 2x. So I'm just going to bring down my 6x first. So 6x negative 5 times 20 is negative 100. And then negative 5 times negative 2 is positive 10x. Okay? And I almost forgot to write the equals 12. Whoopsies. So I know it equals 12. So right off the bat, I see that these are like terms. Let's go ahead and combine them. Okay, so 6x plus 10x is 16x minus 100 equals 12. Okay, now let's move that 100 over. I'm going to add 100, add 100. That leaves me with 16x equals 112. Goodness. So let's come over here, and I'm going to divide both sides by 16. I ran out of room, so I'm just going to 16x equals 112. I'm going to rewrite it. I'm going to divide each side by 16. Each side by 16. 16x divided by 16 is x. And then 112 divided by 16. What is it? Okay, how much times 16 go into 11? It doesn't. So, 16 going to 112. Let's think about it. And 112 divided by 16 is, of course, 7.